Boiling point elevation. How do you figure out what the boiling point of a solution will be if all you know is the boiling point of the pure substance? For example, what is the boiling point when you dissolve salt in water? Or when you dissolve sugar in water, or anything in water? Well, I can tell you that the change in boiling point is predictable, because every liquid has a Kb, or boiling point elevation constant. This controls how much the boiling point changes based on how much is dissolved. The trick for you is that it's not based off of molarity or moles per liter. It's based off of molality, which is moles of solute, or the thing that's dissolved, divided by kilograms of the solvent. I'll show you how that works in just a second. Now, some teachers may give you the formula I Kb times m. I here represents how many particles the thing breaks into when it actually dissolves in the water. Here's what I mean. If you dissolve 1 mole of, I don't know, NaCl inside of water, you're not getting 1 mole of foreign particles floating around in the water. NaCl breaks up into 2 separate ions, so you actually get 2 moles of foreign particles floating around. This I helps control for that fact, because when you're talking about how much the boiling point changes by, it's changing because having different things dissolved in the water, whether it's a sugar or a salt or an ion of some other kind, those ions and molecules are interacting with the water molecules with like dipole-dipole forces and hydrogen bonding and ion-dipole forces and London forces and all that other stuff. And it's making the molecules of water less likely to escape or boil away. Point is, it depends on how many foreign particles are in the solution. So, let's do it. Let's figure out the boiling point made for a solution of 79 grams of sugar. This is sucrose, dissolved in 100 grams of water. First things first, we need the molality of the solution. That's moles of solute divided by kilograms of solvent. How many moles is this? Well, it's 79 grams, and to convert grams to moles, we divide by the molar mass. The molar mass of sucrose is 342, trust me. And we have to divide that number of moles by the number of kilograms of solvent. Watch out, it's got to be in kilograms, and in this case, it's 100. Notice I said solvent, not solution. We're not dividing by 179 grams. It's only the mass of solvent that we care about. 79 divided by 342, that many moles of sugar, divided by 0.1, gives me 2.31 moles per kilogram, which we call 2.13 molal. So, here we go with the formula. We end up with the change in boiling point is I. Sugar doesn't break up. It's not an ionic compound, so it's not going to give off more than 1 particle when it dissolves. It's just going to stay the way that it is. Times the Kb for water, which is 0.512. Put another way, for every molal of foreign particles, the boiling point goes up by half a degree, and we have to multiply it by 2.31 molal. When you do that, you end up with 0.512 times 1, 1.18 molal. Ignore the fire alarm that just went off in my building. Okay, let's do this quickly. The way that you're going to figure out the boiling point for this one is the exact same way. You're going to need the number of particles that CaCl2 breaks into. That's 3, because you'll get 1 calcium and 2 chlorines. The Kb for water is the same, because it's the Kb for water. And now we just need the molality of this solution. Well, what's the molar mass of calcium chloride? You have to add up 1 calcium and 2 chlorines. I get 111. Let me just do this little calculation to the side. The number of moles here is 20 grams divided by the molar mass of 111. 20 divided by 111 ends up with 0.18 moles. And so the molality is, divide that by, again, 100 grams of water, or 0.1 kilograms. You end up with 1.8 molal. 1.8 molal. And when you do this calculation, the boiling point goes up by 3 times 0.512 times 1.8, 2.76 degrees Celsius. This solution, the first one, boils at 101.18. Wow, I used the completely wrong unit there. Went up by that many degrees Celsius. 101.18 degrees Celsius. This second solution boils at 102.76. Keys to figuring out how much the boiling point goes up by is using the right KB, which they should give you, remembering how to calculate molality. That's moles divided by mass of solvent in kilograms, and knowing how many pieces the thing that's dissolving breaks into. Covalent compounds stay as one. Ionic compounds break up into ions, and you'll have to figure that out on your own. Hey, best of luck. And now I gotta leave my building. Take care.